Okay. Way too fucking late. Shouldn't have started this late. I'll go at least an hour, maybe an hour and a half. It should have been a lot longer. Oh fuck. I think I have time to upload this, so I'll go at least past then. Oh, I think that's the one. Looks like. Oh, wrong channel. Real quick. This one. Yeah. Yeah. Okay. So yeah, this one is a new one. Cool. Oh, yo, please. I hate fucking YouTube. Okay. Cool. Okay. Really should be a lot longer today, but I had to read some shit once I got home. Doing this book club thing tomorrow, and I had to finish a book. So I had to spark note it because the book's not super interesting, and I didn't have time. Didn't have time, and I mean that's really the primary reason. But after I read it, that took away from my usual chill time, so I just spent like an hour reading. So I chilled for an hour extra, and then because of that, I was in like a mega chill mood, and then I need to do it. It's harder for me to get locked in for coding if I start too late, so it's a mistake. I'm weak. I need to get better. So I'll do it hardcore this weekend. I'm gonna wake up and just go straight to it, get locked in, because I still want to do this. So. Alright, we'll do the quiz from scratch again. Alright, yo. Oh, I never bookmarked. Did I? Wait, oops. I really didn't. Wow. Yeah, because we did part 2. Oh, wait, no, we're already here. Okay, so this is the one. Alright, so start from scratch. This, and then I think I have to upload the other one too, because I did game dev too. So we'll do that real quick. Okay. Real fast. Cool. Okay. Why are named constants better than literal constants? And then are these? Okay, because one, when we're debugging, the hashtag defined the macro constants, the pre-processing directive or conditional whatever the hell. These guys, we can't watch these variables in the debugger. So there are debugging considerations. They're less well known in practice, but I guess it's subjective because if you were already practiced in them, then you would already do that. So the main issues are it's harder to debug because the debugger literally has different functionality for them. It doesn't capture those symbolic constants, so aka just the identifiers that you've defined. And there are also scope concerns because the preprocessor directives behave for the entire file instead of having different scopes. There's no local hashtag defined thing. Why are named constants a better choice than literal constants? Readability, maintainability, and you can change them in one place. So I could have one constant that is named and we'll call them gravity up at the top. And let's say for some reason in 1,000 years I have to go and update this program and gravity is now 10 meters per second squared for who knows why, or it's 9.7 instead of 9.8. I think 9.82, isn't that what it is? I don't remember. It's been a while. Well, I can just go and edit gravity and it will update everywhere that I have used gravity instead of having to go and update the hard-coded, magic number. There's basically magic numbers, literal constants, unless I mean, pretty much. I mean, sure, it might be redundant at some point, but I mean, it makes sense to make a literal constant or a named constant instead of a literal constant anytime you ever do it. Except, I mean, I guess 0 and 1, but you could say 0 is true or true is 1 or whatever. Variable true is 1, something like. Well, you can't do variable true. You could do. I mean, I guess 0 and 1 and -1 probably makes sense. But yeah, readability and being able to edit them all in one spot. So makes sense. Harder to understand. And we can also change them so that it updates every value it's been used. And then these guys, debugging and scope considerations. Yeah. And the scope considerations lead to the naming conflicts. Because I could use X in main, and then I could use X in another function, print, as a parameter or whatever, or just a local variable, same shit. Well, excuse me, I would have a name conflict if I was using define X as whatever and then use X here, use X there. But now I can actually use X twice. I have more identifiers that I can use. Excuse me, 3 issues in this code. One, we're using an unsigned int. So well, the issue isn't an unsigned int. The issue really is the 8. So we're only using an integral type that has 8 bits to it, and it's one of the extended ones that comes from C standard int. So I mean, it's in native C++, I guess, if we say that the standard library is native C++. But in terms of the things that aren't included and that are in here by default, when we do stuff with this 8-bit guy, C++ uses the functionality of the default, the integral 8-bit type. And the only default one is the character, because characters are default 8 bits, integers I think are 16 or 32, maybe depending on the system. So you're going to get character behavior here, where 1, if we extract input from the user and we put an age, if someone puts 67, well, it's going to extract 6 and then leave 7 in the buffer of character input. So it'll say 6, 7, and it'll pop 6 off and then go and store that as age instead of 67. So it's character behavior. But the other part of character behavior is that whenever we do something to it, well, so actually in the same sense, we're storing it as a character. So it's taking the character value because it's treating this as a character because we haven't casted it or anything. Well, and it actually wouldn't even matter. It's just because we have a variable that is literally this type. We could print it and cast it, but because we're storing it, we're actually storing the ASCII value, which is 48 higher than whatever the number. So if we stored 69, I don't even know what well, 69 should be 54 and then 57. Right? Yeah, I think. So it's going to store the wrong value and it's going to store part of the value, one character. So you're limited to one number and it's the wrong number. Another one here is that age is 16. This should be like age to drive or legal driving age or something like this. Some variable. This isn't a magic number. So if Texas changes the law for driving, then we can update it and then it updates here. So if age is greater than or equal to the driving age, something like that. And then the other is that this period and then \n for the inline escape sequence. This is one character. This is another character. Combining them is going to screw it all up. It's going to... Seems like it's going to... What's it going to do? It's going to give a different ASCII number. I don't know if it's going to add it up or how exactly it's going to happen, but in short, it's not going to give the ASCII code for this guy, nor is it going to give the one for this guy. It's going to be some kind of extra shit, and it is not going to end the line. It's going to print some kind of craziness. So one, we need to be using like a default integer type here, so not the 8-bit version. Doesn't matter if it's signed or unsigned, in this case unsigned. We're using a magic number, and we're not using the correct character here. This period should be either at the end of both of these, or there should be quotation marks here to do the end. Yeah. It's typically defined as a character type here. Yeah, so 1, it's only going to pull 1. and it's going to add 48. So also true. So when we do that and we change this to being an int, we were using C standard int to get these extra int types, but we don't actually need them, so we can remove that. One less header, bunch of for declarations we can remove. The primary differences between standard string and string view. Let's see. And what can go wrong? Okay. So standard string is an owner, whereas standard string view is a viewer. So if we do standard string, and then we name him X, we'll just call him string. We'll say X, that's fine. X, or text, we'll do text. And then we assign it something. Text is given some piece of memory, and that's determined by probably the length it's initialized as, with. It's a little bit of memory, and it owns that. So as that let's see. So it is reporting directly the value that it is tied to, the little bucket that it owns. Whereas string view is different. It instead watches something. So its value is not the thing. It is, does it even have a value? I don't even know if string view has, I guess string view stores a pointer or a reference. It's basically storing, is it storing a location, or it's storing like a direction to some other value. So if I do string view text, and then I give it a C style string literal, and we just call it, this is text. There's a temporary variable created somewhere, so it's undefined, or not undefined, but not identified. Doesn't have an identifier. There's a literal in there. What a literal constant, I guess, instead of a symbolic constant. So it's a literal constant, but there's a variable. There's some little piece of memory that has that somewhere. Especially because if it's a C style string, it's alive for the program's lifetime. So there's some temporary variable, and it has this value. And string view does not take that value and store it. It just has a little window that points to it. I don't want to really say point because I don't know if it's a pointer. I don't know about pointers yet. I haven't learned that yet. From this resource, at least. But it is storing some, it directs you to that value. So if this value changes, then the value you see when you print it or when you use it will change as well. The primary differences are, when you modify a string, a standard string, you are actually modifying the value that it is associated with, it owns. You're modifying the value that it owns. Whereas with string view, if you modify the string view, all you're doing is changing what the string view has been assigned to look at. Whereas in string, you're assigning the value. You are changing its value. You are taking what is in the bucket and replacing it with something. Whereas in string view, the bucket is looking at something. All you're doing is putting another thing for it to look at, but it doesn't actually own that new thing. So instead of me putting in something that it owns, I'm putting in a new thing to look at. So I'm giving my buddy another picture to put on his wall to look at, but I'm not giving him whatever's on the picture. Versus me actually bringing him a bowling ball. Now he owns that bowling ball. So string view is not responsible, whereas string is responsible for its values. So if we change the string, the values actually change. Where string view, those values do not change. It is not tied to. It's tied one way to its thing. So you could change the string view, and whatever it was looking at doesn't get changed. I could have a picture of a bowling ball on my wall, and I could scratch it up and whatever, and nothing happens to the bowling ball. But if I do have a bowling ball, and I put a marker on it and change stuff about it, and I change its values, the value actually changes in the string. What can go wrong with a string view? Well, if something happens to whatever value that it's watching, and you're not expecting that, then the value will change in string view because it is seeing that. So if we have, let's say, we have a string view, and we're returning a string view from a function, and the string view is assigned a local variable in there. It is looking at that local variable. Once we leave and we return that string view, we get the string view, but then once the function ends and that local variable has been destroyed, then string view is now looking at a variable that doesn't exist, which will exhibit undefined behavior, which is determined by the implementation. So your own compiler, IDE, those things. What else could go wrong with a string view? Let's see. And you can't use it to change another object. You can only assign it an object to look at. They can be constant expressions because they don't actually, the values, let's see. If the values are known at compile time, like a C style string, and it's a literal constant that can't be changed, that's fine. What else could go wrong with a string view? It's like if the value is changed, then you'll get some undefined behavior. Oh, also they can be invalidated. So if the string view is looking at something and then we change whatever that thing is, specifically if it's a standard string, or mainly also if it's a standard string, then that will invalidate, meaning it will kill your confidence for whatever value this was. So if something happens to the value this guy's looking at, the bike or the bowling ball, my buddy got a bowling ball, he sent me a picture of the bowling ball. Cool, I got a picture of the bowling ball. Well, that doesn't actually make sense. It's more like a live stream. He gives me a camera and I'm looking through and it's a live stream of the bowling ball. Well, excuse me. If he does stuff to the bowling ball, well, what I'm looking at probably doesn't look like how the bowling ball used to look. Maybe it looks pretty similar, but maybe it's totally different. Well, in that case, it would look exactly like whatever the change is. But for string view, it's not so simple. So the changes here are not necessarily exactly reflected here. It really depends on the size of the string if it's changed, because if the string is large and we have string view that's looking at it, but then we resize the string to be smaller, then not only are we going to show the new value, we're actually going to be showing a bunch of extra stuff. And when all that binary is put together and we display it, it might screw up some of these values. Instead of just like displaying the accurate stuff and extra, it might actually just be junk. Same way if it's small and then we extend it. So we're looking at it with a string view, and then it gets larger, the string view is still going to be looking at this smaller thing. And I think, let's see what happened. Smaller and we expanded it. Then the string view isn't prepared to look at something with such a large memory, which that's the one that I've seen really get fucked up. If it's big and it goes small, then it's fine because we still have enough memory. But if we go small to big, and we're still looking small through it, I don't even think it was a piece of the whole. It was just totally screwed up. What else could go wrong? It says read only. Oh, true, the costs. So standard strings are expensive to copy and initialize, so we want to try and use string view whenever we can. Because we're only passing a reference or a pointer, some sort of directive, some sort of look over here kind of thing. I get, like, what do we even say? Like a resource? We're passing some sort of bridge, some sort of guide to something else. We're not actually taking that thing, making an entire copy of the bowling ball, and then moving it to my room. I'm just taking a picture of it. I can still do all the stuff to it. I can still zoom in and look at it. I can still pick up the bowling ball and look at it. I can do the same shit that I would do either way. I just don't have to make another one else. Read-only string views are not expensive. They can be dangerous when the string is destroyed before the string view that's viewing. Yeah, because if the string is destroyed, the string view will see, oh hey, alright, we're looking at this, but then, oh, this doesn't exist. Well, what is it looking at now? Maybe whatever values are now currently there, maybe something else that's just undefined. Not really sure. Alright, a program that asks the name and age of two people, then prints which is older. And then, why can't this be a constant expression? Well, it should be. Excuse me, assuming this is age 1 and this is age 2 for person 1, person 2. So name 1, name 2, age 1, age 2. Age 1, it seems like neither of these can be a const expression. The reason why is because these are entered by the player. So these are by definition known only at runtime. And if it's known only at runtime, it can't evaluate to a constant at compile time. Because one, it has to evaluate to a constant. But because it's a constant expression, it actually has to evaluate at compile time. So because these are both references, or sorry, because these are both runtime known, or what, runtime expressions, I guess? Non-compile time expressions, they can't be const expressions. So, nor are, let's see. I mean, I guess you could assign them to a constant string. So the const part doesn't matter. No, but well, it also depends on the version too. If you're in C++ 20 or after, then there are const standard strings. But if you're before, there aren't const standard strings. So even if, let's just say this was in the program, we weren't even extracting this using character input or get line, which is what we're doing. Well, maybe. Because we could do either way and then cast maybe. But if we just made a variable and said this and said that it was a standard, well, this isn't even going to be a string, but, well, hold on. Yeah, nobody said this is a string. Hold on. If these are integers, then yeah, sure. Constant integers that are known at compile time are const expressions. But these aren't known at compile time. It seems like that's the answer. Because if they were, we're cool. If they happen to be strings for whatever reason, I mean, they're not going to because we can't do math with things if they're strings yet. I don't know how to convert between these, so I don't know how to get an int and then convert it to a string, nor do I know how to get a string and then convert it to an int. Feels like it's the runtime stuff. Okay. So enter a name and then we'll do some getLine stuff. Then we'll do that. And then person. And then we will report name. And then age something that. Okay. Alright, so the best way of doing this might be continue question 4. Okay. So what do we need? We need input for sure. But we also need a string for sure. Do we need, I'll do string view as well just in case. I'm not sure if I need it yet, but we'll find out. Okay. So we need two extracted, we need 2 strings, we need 2 integers, and then depending on the integer, we report certain stuff. We could do a function. So we could do a function that gets and then returns, and then we could figure that out. And I think it might be okay if we're doing a string view. We'll find out. So, okay. So we need a string. And the string is name1. And we get that by acquiring it. So we'll just call it get name string. It's fine. Get name string for now is okay. It is a function. So what do we want to do? Do we want to do a string view? Because if we do a string view, we could do some cast action. I'll make it work and then I'll try and make it less expensive. So we want to return, we're returning a string. The function is called get name string, get string name, I don't know. Okay, and no parameters, yeah. Okay, so what we're going to do is we need a string. Yeah. Need a string and we'll just call it name. And we'll value initialize it 0. And then afterwards, we need to extract. So we'll do standard get line. Right, that's the thing. Yep. But do we? Yeah, because we're not doing a character, so we can't just do character input. We need to do get line. And we need to do the white space because at some point I'm going to be extracting something. So at some point I'm going to extract something before I get one of these names again. So if we don't do white space, it's going to take whatever end line that I used to submit the last extraction, and it's going to include only that and then nothing else. So we needed to ignore that end line and keep going. So we're going to do standard character input, and we're going to pass in standard white space to ignore the leading white space before this. And we're going to extract him to name. Just build this guy real quick. He doesn't return yet, which is fine. And then I think we're just going to return name for now. Let me see. So we have a string. But the problem is, so we're value initializing him, which is okay, we're not even value initializing it. We're initializing him as, we're creating a string, but then we're passing in my value. And there could be a better way of doing that. Maybe. Okay. I'm gonna just get the program working first. And then we're going to do, we just need an int. We need int age1. Yeah, and the value's not const. So it can't be a const expression because it's 0 here, but then later on we're changing that value. So it can't be const. Yeah, because we can't create the variable in the extraction. So far we have to create a variable and then extract to it. So in this place we can, or in this instance we can do, can't we do character input? Pretty sure character input works for this, right? Doesn't it? I don't remember. I'm pretty sure character works for numbers, right? I'm just gonna do that real quick. So I'm just gonna do whatever, and then 2, 4, 5. Okay. So character input is cool for numbers, but for strings it's not cool. Excuse me. Okay. So that's fine. Okay, so we're going to initialize age1 as get age int. Or we'll just say get age. Get name, get age. Why we don't need this. Okay. It's fine. Guy's not defined yet. Oops. This is a function. I need to fix this. Int age1. We're gonna initialize them as get age. Oops. Cool. And we're gonna have a function that returns an int, and it's gonna be called getAge. It's gonna have no parameters. We're not doing a for declaration, nor are we doing that crazy syntax. And we're going to have an int, and it'll just be called age. Value initialize them so that we can do standard character input into them. And then we're just gonna return age. This is cool for now. Oh, wait, hold on. Yeah, we're not using them yet. It's fine. If we just do that, then it's fine for now. Okay. So we need function to get names. Well, what do we need to get names? Well, this is straightforward, honestly. We don't even need a comment here. Need to value initialize before extracting. Need to ignore white spaces because we'll be extracting before getting a name at some point. Name later. And then same thing. Must value initialize before extracting. Or well, it should value initialize. That way we get rid of the garbage value here. Or we'll just say remove garbage value before extraction. Oops. Okay. And this is cool. Okay. So it feels like we do this and then that, and then we do same shit. Another one, just call name 2, get name, and then age 2, get age. Cool, and that's fine. Those aren't used. That's fine. And that only happens because these are ints with standard strings. We don't get asked to use them. I am curious if I did int age 3. Actually, if I did standard, I'm curious. Let's find out real quick. It's supposed to be alphabetical. If we include C standard int, that way I could do, or oops, C standard int 8t age 3. Oh, it does actually have an issue. So it has an issue with integral values. Not integrals meaning integer-like values or integer behaving values, but integral values, characters, booleans, integers. So it's cool with these, but even if we use the standard string or the C standard int, the other memory type ints or other memory quantity under other size ints, excuse me, still wants us to use them. Okay. So we'll get to these, and then we'll have a function print older. Print older. We'll just say print oldest. Print older. Which one? And then we'll just pass it. Do I even want to? Do I want to pass it both? We could do a string view. I think that's what we do. So we'll pass it name 1, age 1, name 2, age 2. And print older is, it has string view. That way it just views this because he isn't changing. This might be where the optimization part is. String view. I'll just do I do same one? Name 1. Name A. Int age A. Standard string view. Name B. Int age B. It's fine. Okay. So yeah, the parameters aren't being used right now, which is also fine. So we'll just say if age A, let's see, prints the person that's older. So what's the best way? We could do if age A is greater than age B. Do I need the 3 conditions? I feel like I might. Yeah, because it's not just 2. It's not do this or this. It's this or this. So either we print this guy or we print this guy. Or I want another one that prints that they're the same. So we'll just do, yeah. If age A is greater than age B, we'll do this. Just do age A, whatever. Otherwise, if age A is less than age B, then we'll do, and then otherwise they're equal, and that means something else. So what are we actually doing in these? What we're doing here is if age A, then we're watching it. So Print. So. I don't want to use the logic twice. Whatever, I'll get the function, get it going. Oh, I want to think a little bit in the beginning rather than writing it, making it work, and then thinking more to fix it. It might make sense to think first. So I'm thinking either I could, because this will have this will have similar stuff. So it'll say age B or whatever. It'll say like output this name space, or so there'll be. It'll be like. It'll be name A. Age A is older than name B age something. Because this is going to be similar. Whatever. Or oops, we'll copy it for now just to make it work. This is B. So this is I'm already doing the, was it DNR? Do not repeat yourself. DNYR or don't DRY. Don't repeat yourself. DRY. Name A, AJ. Otherwise, output name A and whatever. Age A and oops and name B age B are the same age. Okay. So if one guy's older, then we'll say whatever this, but then the other, if the other's older, then we do this. Otherwise, they're equal. I'm just gonna test this real quick. Oh wait, we don't even have any prompts. So what do we want? Enter the name of person one. So we'll do. Yeah, we could do something like enter the name of person number. Person number. Int person number. Int person or what is it? Person number to the age of, oh fuck me, it's more. Person name. This needs name too, so that these pass that. This will say enter the enter the age of person name. I think that's how it'll be. Person number something. So that'll be 4, and then this will be colon space like that. Hold on. Get name, person number 1, person number 2. Huh. So it'll be enter the name of person 1, Jason Statham, 34, Ethan Jackson, 32. And it'll say Jason Statham is older than Ethan Jackson. And then if we do the same shit and we say Ethan Bippo, 88, Jilly Billy, 33, cool. And it works. And it's probably pretty damn good. But I'm just speaking stupidly. Alright, so we did end up needing string view. Okay. This is person number 1. So there's the first person, the second person. Or we could do, would we have a tracker inside here that would tell? I think right now we would need to pass it as a parameter. Yeah, because the function creates the variable, so it needs to be passed. I think we need to pass it 1 and 2. Because there's no way for the function to track how many times, unless there's just a global variable that is like times called, and then this increments it and then prints it. And then the second time you do it, it increments it and prints it. So it says person 1, person 2, and then person 3, and then person 4. Feels like that's the only way to have, without manually passing it a value here, but then we're putting it here. Yeah, I don't know. Person 1. Okay. So, how do I remove some of this repeating myself? We could do... We can do another function called void... So I could either have those or have another function that puts them. And we could say, we could pass it takes them in that order and then says they're equal, print equal or not. Like, does it even make sense to have those functions like this, or does it make more sense to just leave it like this? Let's see. Let's see if there's any optimizing to do. So how this works, we create a string. So we have a string, excuse me, name one. So, so we initialize them to be, we call get name and we pass it what number of the person. So we have a string and we're only passing it an integer, okay? And then we are creating a string. The point of string view is to let things watch when possible. But here, there's no value here to watch. We're creating this value first, so there's no way that this guy can watch this, nor can it change that anyway. So we do have to value initialize a string and put a value in there. And then we can't return a string view because once this ends, this value is gone unless we have a string literal. But I don't even know how to create a string literal variable. We don't do that. So, and it can't be like, so if we created, if I assigned something a literal and then I could return a string view to that literal, and that would work if it's a C style string because then It's a C-style string literal, which means that it stays in the lifetime. It's alive for the whole program's duration. But we need to actually extract the values, which means I don't think there's a way we can view here. So I think we do actually need to return a string. So we are creating a string and we are one time passing it by value. But it's not that bad. We're literally just creating a string and passing it, which is more expensive than just creating it. So, and I guess this is technically more expensive than just making an empty string and then extracting its value. But we're still passing it by value. So creating this guy would be value initialized, and then we would be extracting it, and then we would still be copy initializing it, which is copy initializing. Well, it's actually not. It's list initializing is this. It feels like it's about the same. I don't think it's a big issue. And then we're getting an integer. So we're calling get age, and we're passing it what age of the person. So in this case, we're just saying name one. Who's the person we're what is the name of the person whose name we're getting? Whose age we're getting? So we prompt the user. And we say, yo, enter the name of whoever the fuck, or enter the age of whoever the fuck you're getting the age of. Value initialize, extract it, return that. That's fine. It's not a string, no issues here. Another one, we get another person, we get another thing. And then we need to do the comparison. We need to print who's older. So we print the people. We don't have a struct, so we don't have like a person struct that has a name and an age. I don't even know how to make structs at this time. I haven't learned yet by this resource. So we pass it both people to do the comparison. Or we could say here we can have the condition in main. I think that's the way we do that. I think we say, actually here we do if age 1 is greater than age 2. We do print older name. Well, we still have to pass everything, but it does get rid of the redundancy, maybe. So we still need to print everything. Let me see this. Okay. We still need to know everything. We still need the thing that's printing needs to know who the older guy is and who the younger guy is. So we still have to pass all 4 things. So it feels like it's actually okay here. Let me make sure my functions are only doing one thing. So in here, we are getting a name. What are we doing? Prompting a user and value initializing a string and getting input and returning it. That's all just getting a name. That's okay. Here, we're prompting a user for an age, value initializing, extracting, returning an age. I think that's okay. Here, we are doing a comparison. Hold on, let me see. No, we're not. We're just saying, print the older motherfucker. And then here, we are printing the older motherfucker or that they're equal based on conditions. I think this is the best way of doing it. I was going to say we could do here, if, else, whatever, and then we just pass it whatever we need. But we need to pass it everything. We don't just say, Jason, age 32, is older. We need to say who he's older than and what that person's age is too. Which means it makes sense to just call the whole thing here. So main gets people and ages, then prints who is older. Or if they're the same age. So in here, we have a string and a string. Instead of passing them and copying them to strings here, it makes sense to just use string views because it's okay to implicitly convert from these. Well, we're actually not even implicitly converting. We're just taking snapshots of these guys. We're getting views of these and putting them here. And then we're printing. This feels like a really good way. This feels kind of clean. I'm gonna do one Osu song tonight to clear my brain.
Welcome to us.
Oh my god, that's too loud.
Click the circles.
Hey, dude, every day there's another song here. Why? This kind of goes hard. Fuck it. Fuck. I said I'd only do one, but I'm gonna do, well, it'll be that song, but it'll be a higher difficulty. That'll be the rule. It's one song. It's the same song. It's just harder. No. There it is. Oh my god, it's 2.5. Fuck. Oh no. I can't do it. I can't do it. This is gonna be stupid real quick. Oh, it's gonna be bad. It's gonna be real bad. Oh my god. I don't know what I'm looking at.
Next time.
Okay. Alright, refresh. So we're getting a name, we're getting an age, and we're passing that getAge function the name. Is there another way we would want to do that? How are we passing it? We're giving it a string view, so it's viewing that, so we're not passing anything. I don't think we're ever copying any names by value except when we're actually getting the name, which is what would happen anyways, because once we do this, we're going to be copying this. Like if we said whatever name is whatever. Well, actually, we're doing it here. Duh, we're doing it here. In doing this, we're copying it here. I think this is still copy initialization, seems like. So I think that's the only way I know how to even assign it. I guess you could do direct assignment, like equal or assignment operator equal sign, and then parentheses. Direct. Yeah, it's like direct copy assignment, I think, which is somehow different, somehow semantically. So we are copy assigning it, and then we're copying assigning it again. So technically, if we had just pasted this down here, then it would just be one variable being copy assigned. Boom. Instead of variable copy assigned to local variable, local variable, copy assigned to local variable, copy assigned to local variable but in main. Is there a string view way to get out of this to have something watch something? This needs to be copy assigned because we have to extract it. And to get this here, I don't think we can do any string view stuff because it goes away. Yeah. I think that's how we do that. That feels fine. And then in print older, we're passing it. It has string view parameters, so we aren't copying anything here. We're just passing it integers via copy. Copy assignment is just fine, passing by value. Not a big deal. And then we're just printing what's older. I mean, I could have another function that has older name, older age, younger name, younger age. And then we call that function here and then just pass it the arguments in one order. And then we pass them in another order. But I mean, that's kind of just inconvenient. I mean, I'll do it real quick. There's a void print older, and we'll just say actually print older. Well, okay, what would actually be a good name? This should be like, well, this should be print older, so we only call this once, but this would be the helper function, and then we have print older, and then we have, yeah, I'm just gonna say actually print older, and then it takes yeah, I think we do that. I mean, string view, and we do older name int older age, string view younger name int younger age, and then we say output, or let's see, so we'll say if older age, or no, so the whole point here is we're just undoing this. We don't need to do this other determination here. So we'll just say we'll just output older name, oops, older age, younger name, younger age. That's not being called yet. And then here we just say, oops. How do I don't even know how I do that. Oh, please don't open it. Oh my fucking god, you're gonna open another tab, aren't you? Okay, now. Oh, bro. If I just start typing, why does it go there? That's stupid. Why does it go there? That's really dumb. So if we do this, it selects that. If I do that, when I delete it, I then have to do this to type. That's so fucking annoying. Because it selects all the way to there. So we could do Control Shift function end. Nope. Oh wait, hold on. Control Shift end. Because there's end. Hold on. No, it's function end. That's it. Okay, so it's control, not shift. Shift is the whole way. Okay. So just shift function end, or shift end, basically. Like that. That works. Cool. Alright, and we'll just call it actually print older, and we'll pass it name A. Well, yeah, if that's older, then name A, age A, name B, age B. If not, then we'll do actually print older, name B, age B, name A, age A. Or what? Oh, because we haven't forward declared. Okay. I should probably start doing some header guards here and get these guys out. That probably makes sense. Yeah, I'll do that. So we'll do... We'll get... We'll do get stuff.cpp. We'll do another one. Print stuff.cpp. Oh, motherfucker, dude. How do I don't remember how to even find him. Doesn't exist here. Oh yeah, we have to actually find where it is. Here. This dude. Why don't they just get destroyed? It's so ugh. Alright. Now we'll have a print stuff. And now we'll have a get stuff. And now we'll have a print stuff. Let's get some music going again, please. Okay. Alright. So the implementations, we have the get stuff. And these guys are here. This needs to include string, or no, it's just gonna include get stuff.h, and then it will have, bro, you fucker, bro. What? Dude, just paste it. Okay. That's okay. And then get stuff h, because this resolves any return type differences here. So this will have string, string view, and then iostream, right? Doesn't it need all three? It needs string, it needs string view, and then input output. Yep. But it also needs, if not defined, get stuff, define get stuff, and then and if. That way, if this is already included, we don't include the shit twice. It also needs the for declarations. So just copy this guy over. Copy this guy over. Cool. Less issues. Now we have print stuff isn't working just yet. Get might be okay. Oh, because we're not including them yet. So we'll do the stuff that we made. So we need include print stuff. Include get stuff. Okay, this should be alphabetical. That. Those are cool now. Yeah, it's fine. Okay. And now we'll move this guy over into print stuff. This needs to include print stuff. Oops. Cool. And print stuff will include the same stuff, I think. Both of these, and then luckily inside these guys, they should already have header guards. If not defined, print stuff H. Define print stuff H. And if. And then here. Got one for declaration or prototype, whatever. Oops. Cool. Cool. Okay. Alright, so now in the print stuff, so we have a function for getting the name, a function for getting that, and in here, all of those are already in, so it doesn't matter. The order doesn't matter because they're all already forward declared. So they're forward declared in here, and then they're implemented wherever. So they're both already in here. It doesn't matter. Let's see. Because we've already seen both before we're executing things. Yeah, they're both already seen by this file. So there's no case where this file is only seeing one. It's seeing both, which is cool. And why that's the case? Because we're including these, so all the headers are already in here. Oh, and that's because they've already been, yeah, they're all already forward declared before they're even implemented. So the headers are already up here. And everything is already cool and valid. So we're solid. We don't care about the implementation. Everybody's already been seen. That way they can be implemented, or they can then be used. Rather than them being implemented and relying on each other, but not seeing each other yet. Cool. And we could just remove this. We could copy this and put it in here twice, but then we're violating DRY, don't repeat yourself. So here instead, I mean, this is still kind of repeating myself, but there's, excuse me, here is just, excuse me, prints whoever is older, excuse me, if they're equal. Cool. And then does the, prints the older without repeating syntax, person, and age. Cool. Okay. Gets names and names plus ages. Prints whoever is older or if they're the same age. Okay. Jackie Y, 88. Billy G, 32. Jackie's older than Billy. I'll try it again. Billy, 22. Jackie, 19. Cool. Okay. Works. have header guards used. We have conditions used or conditionals used. So these are still movable. What if I did that? What does that even mean? I don't even know what this does. Oh, it puts it at the top. So if we did print stuff, it's there. But then if we do hello world, oh, we pin it in the order we want it, I guess. Instead of just organizing it to be in the way we want. Yeah, I don't know. I like how it does this. It's jumpy. It's cool. Instead of it being the Windows wonky way where there's delay like that. There's so, dude. Why did it even go white there? I don't even understand why it does that. All right. Damn, 30 more minutes uploading. Shoo. Oh, it is a 3 hour video. So. Okay. Oh fuck. I'm almost done. Rated an hour and 10. Yeah, I'm getting better at this. I need to just keep going. No pussying out and doing less time because I went chill mode. Yeah, whatever, dude. It's inspiration. There's a reason I'm trying to become more creative and more locked in and wanting to do this. It's because I'm inspired. So there's no issue with staying inspired. All right, final check. We're getting a name. We're getting an age, a name, and an age. Let's just step through it, see how it looks. Getting a name. This guy's 0. We value initialized him for what we're supposed to. Isn't it prompting? Okay. Name, person, numbers 1. Value initialized. Did we even value initialize? I guess we did. But it still has something. Yo. Oops. Yo. Oh, I can't even type in there. Good. Oh, goody. See what happens. I clicked X here. Restart. Oops. So if we do this, step in, step in, step in, step in, step in, step in. Oh, okay. Yo. Okay. So that's where it is. It's yo. Okay. And then we go to age. Go into age. We output some shit. Value initialize. We extract. Say 33. Then we return. End. Okay. Go to name. We initialize that parameter by copy initializing. We output some shit. Value initialize a new string. And then we jump to name and then do get line. Why do we do that? Why does it? I don't know why it does that. That's weird. Okay. And then we get line, say, hey. And then we return it and then go. Get an age, whatever. We'll just step out, go next. And the age is 88. Print older. Pass it via string view, so it's okay. So these are initialized, or well, they're not initialized. They're just looking at the same pieces of memory with those values. Didn't have to copy them. Okay, who's older? So we got 33. 33 is younger, so nope, false. Yup. So we go down here. Output it. Bop. Boom. So we've finished. Return. Boom. And return. Okay. Seems good to me. What was this guy's answer? Input the name using getLine? Well, yeah. I mean, that's how you get a string, dude. Because if you do character, it'll pull. And then the second it sees this, it'll stop. The getLine will continue. Okay. Character input by default will ignore the leading white space, but it will not. So if I was extracting a number and I do 3, enter, so it's 3 end line. It extracts 3, and then the end line is the next character in the buffer, and then there's another extract. It doesn't just extract that end line and then go. It prompts for output because it ignores that end line, so it bumps that end line off and then says, hey, we're empty now, give me another value, and then it asks for another value. But getLine does not do that off the rip, so you have to pass it standard character input so that we can get the input and extract from character input to standard white space. That way we actually ignore that leading white space. Because getLine gets the whole line, whereas character will only do one. So if we did John Bacon, it would only extract John. Uh-oh! He's repeating himself. Holy. Oh, are we doing some constant stuff? I guess so, because we don't want these guys to... And it's a const type, too, so we could do... And we can't do const expression, but it could probably do const. So do const, and then does it have issues because the type? It doesn't. But yeah, we're never doing anything with these guys. We're only doing string, right? We're doing string views. Yeah, we're only receiving string views. So, I mean, is that the only answer? Same thing with const, because we're not changing. We don't want these numbers to be changing. We can't do const expression because they aren't known off rip. Then const 2, I mean, we could make these const 2. Well, maybe. Yeah. And then it receives constant. Feels like that's probably the way. Yeah, I guess I wasn't considering using const yet to make sure that everything was still cool. So we do yo Jill. 1, 2, cool. Okay. Name 1, name 2, print older. Holy. Stole my thunder, boy. Bop, bop, bop. Get name, get age. How did I do the print stuff or the get stuff? Yeah, I did the same shit. Cool. Then get age, passed him a string view. Yeah. Oh, wait, same shit. Yeah, I just called it different. I don't like SV. I like being more specific. Yeah, because I would want to know, like, okay, I'm passing it a string view. What is that string view? I think this is an issue. You gotta say the name of the person whose age you're getting. Then here, okay, but I mean, like, person number? I mean, that makes sense. Person ID? Something like that? Print older? Isn't that what I did? Yeah. Wait, did I do get name, get age, print older? Holy. Man, I straight plagiarize, yo. Oh, now you're cool with name 1, age 1? Okay. See, that's what I was gonna do. I mean, that's exactly what I did. Yeah, see? And then you have to do the kind of the funky stuff here. But, I mean, you could do it this other way. You could do a helper function. So, this guy does the deciding and then just calls a function instead of doing separate syntax twice. We just, because, I mean, the only difference is the order we're putting shit. So, bop. I mean, doesn't matter, I don't think. I honestly think it's better the way that I had it before. Just because, why do I need this extra function, more shit to keep track of? It's just clutter. All of this just to avoid repeating myself once? Come on, bro. Why can't age 1... So we know what age 1 is. Why can't age... this might have biased me to call it age 1, but I probably still would have called it age 1. Why can't age 1 be a const expression? Well, it can be const. It just can't be a const expression because the values aren't known at compile time. right? Yeah, because we can't know this guy's evaluation at compile time. Makes sense. Let's fucking go, bro. Perfection. Operator, precedence, and associativity. All right, now we're getting into cool, crazy shit. Compound expression. Oh, okay. Really? Wait, it's just PEMDAS? Oh, no. Really? I'm surprised. Isn't that? I'm surprised. Order of operations? Really? I mean, doesn't, I'm pretty sure, well, it's gonna say all the shit that I don't need to remember. Oh, well, the OR activates before the literals and operators. Okay. Yeah. And it's not necessarily a statement because we put an operation um, within a conditional. Man, I need to get a D&D character going. Fuck, I have one. I just need to practice role playing. I'll role play him tomorrow at work. That's what I'll do. Yeah, I'll do that. I'll do that. Okay, yeah, that'll be fun. So, 5 intelligence barbarian. His name is Huh. So that when someone asks what his name is, I can say, Huh? Carries a big bag of rocks. I just want to make wrong deals. Like, ask a guy, pay him 1 more, or like 3 gold more to buy something instead of 3 gold less. How about 5 when he only asked for 3? It's such a funny idea. It's not unique, but it's so funny. Oh, and then he has 20 wisdom too. So maxed out perception and everything. But he's stupid. So he's not going to be smart enough to tell people what he sees. He's going to see something and then look over and just be staring at some people sneaking up on the group and then just like walk over and start fighting, but not actually get the party together and tell everybody. All right. So operations, yeah, it needs an operand. Yeah, yeah. Zero or more input values. So it could have 0 operands. So would you say there's an operation within the if statement if it had nothing? Or within a function's parameters, maybe? But the operation's denoted by an operator. 2 plus 3, yeah, 2 operands, so it's by whatever the fuck. By binary. Well, it's just binary, duh. Instead of unary. I was thinking unary for single. Okay. Yeah, it's 2 times 3 because PEMDAS. Oh, hell no. It ain't that. Determine how operands are grouped with operators. Precedence and associativity, which has to follow general PEMDAS. Hmm. Okay. Yeah, it makes sense. Yeah, because we have what is it? Or constant folding. So it'll do the addition of some constant values. And then substitute using constant propagation. Okay, precedence. Assign a level of precedence. Ooh. Precedence level 5. Oh, okay. Really? So there's a lot of shit before that. Wow. Hmm. Hmm. Left to right or right to left? And that depends on the operators. Okay. This minus this minus this. So it starts. Okay. Yeah, makes sense. We wouldn't start from the right for subtraction. Precedence and associativity. Oh, well. Wait, what? Dude, it was just 8. Or like 10:58. And I was looking, waiting for it to be 9. That was crazy. Okay, all right. Well, it's an hour and a half. Back tomorrow. Sorry, I was 2 hours short. That's pathetic, and it needs to be even longer. Really, I need to fade this up till like I get home, and then I just go straight into this because I need to get good quick. I need money. I need experience. I need to start working on my goals quick. I need to get enough money so that I can provide for a family once that stuff gets started. So, I'm not trying to do anything right now, but once something falls on my plate, I'd like to have some cha-ching so I'm ready so that I can keep doing this stuff without worrying about having to spend the extra time making more money or something. I could just spend my time doing this and then make enough money during the day without having to do anything and then without my wife having to work. So, all right, sounds good. All right, more tomorrow.